is not symmetric. No, the student's t distribution is symmetric about the mean, just like the normal curve. The student's t distribution is symmetric about the mean. All right. Then that's number one. Let's make sure we know the properties of t distribution, and then. All right, so number two says, which one of the following properties of the student's t distribution? Select one, or select all that applies. So the area under the t distribution is 1, yes. Area under the t distribution is 1, just like the normal curve. B, area in the tails of t distribution is slightly greater, correct. Slightly greater than the area in the tails of the standard normal. All right, C, at the same sample size, increase, that should be as increases, the density curve of T gets closer to the standard normal, correct. So A, B, C, so far are correct. Let's see D. The T distribution is the same for different degrees of freedom. No, so we don't. If the degree of freedom increases, the student T distribution approaches that of the normal curve. The T distribution is centered at mu. Yeah. Okay, so we don't accept D. We accept A, B, C, and E. Okay. Well, this is a review of student T distribution. Well, we need to start solving problems now. Complete parts A to C. Determine the critical values for a right tail test of a population mean at alpha equal to 0.1. So given the alpha level of significance as 10% with 10 degrees of freedom. If I have 10 degrees of freedom, it means, by the way, let's make sure we review degrees of freedom. If degrees of freedom, df, is equal to sample size minus 1. In T distribution, degrees of freedom is sample size minus 1. So anytime I'm given 10 degrees of freedom, then it means that I have 10 here. So 10 is equal to sample size minus 1. If I solve for and, I'll get that sample size is 11. So right here, sample size is 11 in A. Okay, it says determine the critical value. Actually, so they want me, the first thing is to draw a normal curve. If you're looking for critical value, you draw a normal curve. And it says it's a right tail test. So on the right, shade the critical region on the right. And it's a T distribution, so it is T alpha. This is alpha. Okay, and I'm told to find the value of T at the right. Okay, we can use our calculator, and we're going to do inverse T, just like we do inverse now. So inverse T, area to the left in decimal or percentile. So alpha level is 10%, therefore area to the left in decimal is 0.1. So I'm just going to write 0.1 there, 0.1, because that's the area to the left. All right, so that is 0.1. And then the degree of freedom is 10. Whenever I'm looking for inverse T, the critical value, I find the area to the left in decimal, and I put the degrees of freedom here. So now I can use my calculator to calculate the critical value. So what is the critical value for the 10th percentile at n minus 1 degrees of freedom? So what I'm going to do is second verse. And you see that inverse t is number 4. So inverse t is number 4. And the area to the left is 0.1. And degree of freedom, df, is 10 given to me, 10. And I am going to paste. All right. So it's asking me, my calculator is asking me, is that what you want? Area to the left of percentile is 10%. The degree of freedom is 10. That's what I want. I'm going to enter. Therefore, the critical value is negative 1.37. Be careful. Everybody needs to be careful. This is right tail, but the T curve is symmetrical, just like the normal curve. The T curve is symmetrical, therefore the sign will change, 1.37. So we have a sign change, 1.37. All right, so 1.37 is the critical value. I hope this is clear. So anytime I'm told to find the critical value, all I need is area to the left of percentile in decimal and the degrees of freedom. So in B, they gave me the sample size. The critical, I'm told to find the critical value right here when alpha is 1%. And the sample size is 20. So all I have to do is inverse t, area to the left in decimal 0.01. Sample size is 20, therefore 20 minus 1 is 19. So degree of freedom is 19. So I'm just going to pull my calculator up and do what I did before. So if I go to second distribution, I will select inverse t, number 4. The area to the left is 1%. Degree of freedom is 19. And I'll calculate. When I hit enter, and it tells me that the critical value is negative 2.54 to 2 decimal places. But I need to make sure I know whether it is to the right or to the left. So it says to the left. So make sure I draw a normal curve showing that it's area to the left, and then the T alpha for area to the left is negative 5.4, so negative 2.54. Negative 2.54. Okay, and we're going to do C also. Let's do C. In C, I am going to pull my whiteboard. So we're going to do 2 more critical values and we're done. We go ahead and start finding. All right, so I'm picking a brand new whiteboard. And all right, so there I have a new whiteboard, fresh whiteboard. The question in C says, determine the critical value for a two-tailed test of a population mean at the alpha level of 1%. In other words, the level of significance is 1%, but it's two-tailed. Based on sample size of n equal to 11. So we know the information. N is equal to 11. Alpha is 1%. Alpha is 1%, two-tailed. two-tailed, and this is a t-test, t. So I'm looking for critical value. Critical value. All right, so draw a normal curve, show that I have two tails. Because alpha is 1%, I have to divide alpha by 2. I have two tails. So when I divide 1% by 2, I have 0.005. So this area is 0.005. This area is 0.005. Therefore, I am looking for T.005, T alpha over 2. I want us to know that I am looking for T alpha over 2 on both sides, but the T curve is symmetrical. So if I can find the percentile on the left, the critical value on the left, then I can just switch the sign for the right. Okay, so I'll get my calculator, and I already know that sample size is 11, therefore degree of freedom is 10. So I have everything. I can now find the critical value for two-tailed t-test. Critical value for two-tailed t-test. So I now, I'm going to select inverse t again, 0.005. This is a two-tailed test for alpha of 1%. Degree of freedom in this question is 10 because sample size is 11. And I am going to paste. And then the critical value is minus 3.17. Minus 3.17. I have to be careful. So I can write my answer as T alpha over 2 is equal to plus or minus 3.17. Why? Because it's a two-tailed test. Because it's a two-tailed test. There are two of them. There are two of them. That's a critical value on both sides. One on the negative is on the left and the positive is on the right. Okay. Now I know we have covered it all. So the next one now is do an example of T-hypothesis testing. We have already done the steps. For quick review, let's make sure we do a quick review. A quick review of hypothesis testing steps. So what are the steps again? So I'm going to grab this and move it up. And then we'll quickly write the steps again. You will not have to review again. Okay, so the first step, there are about 6 steps. Steps in hypothesis testing. So I'm going to write the steps again. Steps 1, identify the claim. In other words, state the null hypothesis. But I'm doing t-test this time, so it's going to be mu. I am trying to estimate the population mean. And remember that the null hypothesis always goes with equal sign. Okay, so this is stating the claim. And then the alternative, you can use HA or HI. And then it depends on the claim. The claim tells you whether it's going to be not equal to, greater than, or less than. Okay. And in number 2, you identify alpha, the alpha given to you. Identify the level of significance. Identify alpha. In number 3, find the critical value with alpha. Find critical value with alpha, the critical value with alpha. Step 4, use the critical value to calculate the test statistics. So calculate the test statistics. test statistic. And we need to remember that it is going to be t equal to x bar minus mean over standard error for t. Because in test statistics for t, we already know that population standard deviation is not given to us, it's unknown. And so the test statistics has this formula. Okay, step 5, use your test statistics to make a decision whether to accept the null or reject the null. You do not have any business accepting or rejecting the alternative. You are either accepting the null or rejecting the null. And when you accept the null, then the alternative is not correct. When you reject the null, then the alternative is correct. So make a decision to accept or reject. Make a decision to accept or reject. And then to accept HO, the null or not. The important thing is that you are only accepting or rejecting the null. You do not have any business accepting or rejecting the alternative. The null is the status quo, and that's why you're trying to make a decision. And then also you can use p-value. You can also use p-value to accept or reject the null. Remember, if p-value is greater than alpha, if p-value is greater than alpha, you accept the null. Otherwise, reject the null. If p-value is greater than alpha, you accept the null. But if p-value is less than alpha, you reject the null. Okay, step 6 is to conclude in non-technical terms. Conclude your hypothesis testing in non-technical terms. That means write what you're going to tell those who hired you as a statistician to do the study for them. Conclude. And then actually tell them whether the status quo is still working or not. Does it need a change or not? So step 6 is conclusion. Conclude the test in non-technical term. All right, so we have reviewed the steps in hypothesis testing. We quickly start doing a t-test now. All right, so let's get a question on t-test. All right, get a question on t-hypothesis testing. I think number 5 is a good t question. All right, let's do number 5. To test the null hypothesis, mu is equal to 40 versus mu is less than 40. A random sample of size 25 is obtained from a population that is known to be normally distributed. Complete parts A to D. Part A. If the mean is this and sample standard deviation is that, compute the test statistic. All right, so it's always, all the time, they can start asking you questions from anywhere. So first of all, they are asking you for the test statistic. So you want the test statistic T is equal to X bar given to you minus mean over standard error for T. So calculate that. What is X bar given to you? That is it here. So 36.9 minus the status quo, the mean. And that mean is 40 divided by square root of divided by standard deviation. So which standard deviation are we given? It is 13.2 divided by square root of sample size. The square root of sample size, by the way, what is the sample size given to us? 25. Square root of 25 is 5. And so we can go ahead and finish the calculation. 39.9 minus 40 36.9 minus 40 is approximately 3.1, negative 3.1, divided by, we have 13, I have 13.2 over 5 here. So I can get my calculator and put this quantity in. So numerator. So the numerator has negative 3.1 divided, and I'm going to use parentheses, divided by 13.2, 13.2. There's so many ways you can do this. Actually, I can flip that over. Let me flip it over before I continue. I have it's negative 3.1 multiplied by 5 over 13.2. Okay, so that is going to be quicker for us. So that way, I just have 13.2 multiplied by 5 multiplied by 5, and I have an answer. I divide this answer by 13. Okay, I need to, that is negative 3.1. So I'm typing it over, negative 3.1 multiplied by 5. And then I have negative 15.5. All right. Then I'm going to divide this quantity by 13.2. So divided by 13.2. And I have negative 1.17 to 2 decimal places. So I calculated the critical value. The critical value is negative 1.17. So that is the critical value. I put it here, negative 1.17. All right, so this is the boundary line for rejection and acceptance. Now, question B says, if the researcher decides to test this hypothesis at a level of 1%, in other words, 0.1, in other words, 10% level of significance, determine the critical values. All right, so although technology or t-distribution table can be used to find the critical value, in this problem, use the t-distribution table given. Okay, well, you can use that table, but you know what? I am going to put this in my calculator. I am going to go to STAT, arrow to test. I'm doing a t-test. Okay, and before I do this t-test, I want to know if it says, if the researcher decides that to test this hypothesis at, okay, determine the critical values. All right. All right. Although the technology, okay. So I want to find the critical value at 1%. Okay, that's fine. I can now get the critical value. I just need the number of, okay, 25 is sample size. So I'm going to get the critical value. Second distribution inverse t is number 4. It is 0.1 because it's 1%, 0.1%. In other words, let me see. Let me make sure. That is 10%, which is 0.1. The degree of freedom is 24 since the sample size is 25. So the degree of freedom is 24, and I'm going to pass therefore the critical value is negative 1.32. So the critical value is negative 1.32, negative 1.32. Okay, so I found the critical value. All right, what else is the question? Let's see what did. Draw a a T distribution that depicts the critical region. So I'm going to draw, actually it's drawn for us. So let's see. Let's see what, okay. We want to know, by the way, this is area to the left from the question given to us. So actually, I have to be careful that I pick up area to the left. So it has to be area to the left. It is not two-tailed because I am given that alternative hypothesis is less than 40. Look at it here. Look at the question. The alternative hypothesis mu is less than 40. So it's a left tail test. Because it's a left tail test, I will draw a normal curve that it is left tailed. So we have answered that question. And then the next question will be, the researcher will reject the null hypothesis. Well, let's see. Will the researcher reject the null hypothesis? Let's actually see. Because the critical value is negative 1.32 and the test statistics is negative 1.17. So, will the researcher reject the null hypothesis? No, because the test statistics fell into the acceptance region. The test statistics fell into the acceptance region. This quantity is actually in the acceptance region. Therefore, the researcher will accept the null hypothesis. The researcher will accept the null hypothesis. All right, so I'm wondering why my battery is dying. Let me check my battery. It's dying. Okay. Okay, so the researcher will accept the null hypothesis because my test statistics fell into the acceptance region. Okay, let me draw that picture. I'm just going to draw that picture so that if I draw this picture, my calculated test statistics is negative 1 point. Let me pull it down. My calculated test statistics is negative 1.17. 1.17. And the critical value fell here, right here. That is the critical value, negative 1.32. Therefore, the test statistics fell into the acceptance region. This is the acceptance region. And when my test statistics falls into the acceptance region, I will accept the null hypothesis. Okay, so let's go through, which means, let's see. Will the researcher reject the null hypothesis? No. Yes, because the test statistics does not fall into the critical region. No, because the test statistics does not fall into the critical region. Oh, what does that mean? No, because the test statistics does not fall into the critical region. Well, this one sounds to be good, but it's like tautology. Yes, because the test statistics falls into no. It can never be yes, because the researcher will not reject the null anyway. So no, because the test that falls into the critical region, no, falls into the false. Okay, so the answer that is better worded. The wording is not. Anyway, the important thing is that the test statistics fell into the acceptance region. All right, so we accept the null hypothesis. And now that we have accepted the null hypothesis, the status quo is still correct. So now you make a decision. The decision is the status quo is still doing well. We don't need to change it. So we don't accept that it is lower than 40. it is still equal to 40. It's not lower. From the data given to me at 10%, at 90%,